Hi viewers, Olariwaju Bolariwa is my name. Teaching is my calling. What do we have for today? Surd. But before we embark on this journey, let's ask, why surd? You see, surd in mathematics is used to solve mathematical problems in such a way that we will not pass through the complex decimals. We can solve mathematical questions with the use of surd to simplify these complex numbers. For instance, the square root of 5 will give us a couple of decimals, but we can manage this in roots in such a way that we will not pass through stressing ourselves over using calculators or other adding machines. So before we embark on that, we have these numbers which could be rational or irrational. Now let's go to that. Here we are. These numbers are rational numbers. And what are rational numbers? Rational numbers are numbers that we can simplify in order to get the exact fraction. So looking at this 5, we can process this 5 in fraction to become 5 over 1. 5 over 1 is still the same thing as 5. For this, 3 multiplied by 2, we have 6. 6 plus 1, we have 7 over 3. So this indicates that it's a rational number. Let's look at this. This is in decimal. We convert it to fraction. 1, 2. So we have 37 all over 100. By the time you punch your calculator, 37 over 100, it will give you 0.37. That's not all. We have 0.6 as a decimal. So we can leave it as a fraction. It will end up to become, moving it once, will give us 6 all over 10. This is also a rational number. We can present it as a fraction. And finally, this root 49. Root 49 is 7. By the time you find square root of 49, so you have 7 over 1. So the following numbers are rational numbers. Now let's go straight to the irrational number. Right. Now for the irrational numbers, we have these examples. Pi, for instance. So for you to have your pi, by the time I punch my calculator, I want to get the exact figure. So for your pi, which is 22 all over 7, so we have the figure as 3.142857143. You can take a good look at this. To process this into a fraction is going to take a whole lot of time. So it's an example of irrational number. Now let's take a look at root 28. Let me punch my calculator to get the exact figure. Root 28 will end up to give us 5.2915026 and 22. Quite long, and it's going to be extremely difficult to manage while working some mathematical tasks. And to the last one, root 5. Root 5 will give us 2.236067977. You will see obviously that these numbers are very difficult, if not impossible, to manage as fraction. So let's go to the real business of the day. We proceed to this. I have itemized this 4 operations in such a way that by the time we adhere to this, we will not have problem in solving our questions regarding to surd. Whenever you have anything as root a plus root a, it's just like having root a and another root a. It will result to 2 root a. Like root a will become 2. So all we just have is 2 root a. Likewise, when it is root a minus root a, you have a root a and you are asked to remove the root a. You will be left with what? Nothing. So we have 0. Furthermore, root a multiplied by root a. Here, we will solve it like this. The roots multiplied by the roots will cancel each other. You will be left with a. The other way around, you can choose to say root A times root A will result to the A times A will become A squared. And in that case, remembering our law of indices, the square here will cancel the square root, which will result to A. So we have it that root B multiplied by root B will end up to be B. Root C multiplied by root C will end up to be C. So the next one, root A divided by root A, it will simply be 1. It's just like having 5 divided by 5, 1. 20 divided by 20, 1. 50 divided by 50, 1. Myself divided by myself, 1. You that you are viewing this video divided by you yourself, you end up to be 1. So this is 1. Now let's solve some examples. We have these examples to simplify. We have the value as root 45. So how do we simplify this? All we just need to do is to find the multiple of the figure, which is 45. So the multiple of 45 is such a way that one of the two will be a perfect square. What do we call perfect square? Numbers that we can find the root of without having decimal. Like 4 is a perfect square. 9 is a perfect square. 16 is a perfect square. 25 is a perfect square. But numbers like 5 is not a perfect square. Numbers like 6 is not a perfect square. Now, to look for the perfect square for 45, root 45, we can say 9 multiplied by 5. 9 multiplied by 5 will give us 45. So we proceed by saying root 45 is equal to 9 multiplied by 5. So we can find the square root of 9. The square root of 9 is going to be 3. In this case, we have simplified the value of root 45 to be 3 root 5. Because the square root of 9 is 3. And the moment we have found the square root of 9 to be 3, it will leave the root and we'll be left with only root 5, because root 5 is not a perfect square. So by the time you punch your calculator for verification, root 45, what you will have as decimal, will be the same thing by the time you multiply 3 by root 5. Easy. So the second one, root 24. We can choose to say 12 multiplied by 2. But 12 is not a perfect square. In that case, we still need to break that 12 into further simpler form. Maybe we'll now say 4 multiplied by 3. But we cannot think about it like, since 4 can go in 24 and 4 is a perfect square, why don't we just implement the 4 easily? So we now say root 24 is still the same thing. It will say 6 multiplied by 4, because 6 multiplied by 4 is 24. So we have, anyone can come first, 6 multiplied by 4. 6 is not a perfect square, so we cannot find the root of 6 in that case. But we can easily find the root of 4. The root of 4 is 2. And the moment we find the root of 4 to be 2, we leave the 2 out of the root, because we have already done justice to that. So we end up to have 2, because we have found the root of 4 to be 2. Then we are left with only 6, which is not a perfect square. If you compare the two together, they end up to be the same. Now let's proceed to the third one. Root 288. So to think this one straight, I understand that a couple of students might have issues to identify the perfect square that we have as factors of 288. All we just need to do is to simply pick on our calculator to make it faster for us. We can start to divide this figure till we identify a perfect square that matches the figure we have here. So to start with, we can say 288 divided by 2. So if you think that one straight, we are going to have 144. 144 multiplied by 2 will give us 288. 144 multiplied by 2, we have 288. Unfortunately for us, our first move worked. So we simply find the root of 144. The root of 144 is 12. 12 multiplied by 12 will give us 144. So we have the square root of 144 to be equal to 12 root 2. We have our value simplified. Is the next one here, which is multiplication of surds. So we shall be working on this 4 examples. For the first one, root 5 multiplied by root 10. We can solve it in 2 ways, which I will show to you. The first method we can choose to apply here is to say root 5 multiplied by root 10 is going to give us root 50. Because root 5 multiplied by root 10 is to be root 50. 5 times 10, 50. Now from here, we simplify. How do we simplify 50 in such a way that one of the 2 values will be a perfect square? So if you say 5 multiplied by 10, it will not work because neither 5 nor 10 is a perfect square. But what about we think it straight, like root 25 multiplied by 2 will give us 50. Perfect. So root 25 will be what? Will be 5 root 2. Well simplified. You can verify with your calculator. You punch root 5 multiplied by root 10. Whatever you get, keep it. Now punch 5 multiplied by root 2. Definitely you will see that the 2 values are the same. So this is simplified. The other method, before we proceed to the second question, is by trying to break this down. We have our root 5 already multiplied by root 10, which will be further broken down to 5 multiplied by 2. 5 multiplied by 2. We can proceed by breaking this down too, by having root 5 multiplied by root 5 multiplied by root 2. Because root 5 multiplied by root 2 will be root 10. So we see have the same value presented. Now, from what I've given to you here, root A multiplied by root A will simply end up to be A. We now have root 5 multiplied by root 5. This will simply become 5. We now have 5, courtesy of root 5 multiplied by root 5. We have 5. Then we are left with root 2. Then multiplied by root 2. You will see that this and this are the same. So you are free to apply any method of your choice. So the second question. Root 12 multiplied by root 3. We can choose to multiply the 2 first. The value will be a little bit bigger. Then we now look for the perfect square as a factor of the figure we have. But I'm not going to use that. I know if we use that here, it's going to be 36. And root 36 is simply going to be 6. It's going to be so easy. But I'll deliberately take the second method by simplifying 12 first. So the simplification of 12, looking at the factor, I have 4 and 3. 4 multiplied by 3 will be 12. Then multiply by root 3. So if I choose to break this down, root 4 is going to become 2. So I have 2 root 3 multiplied by root 3. We now have root 3 multiplied by root 3 here. Root 3 multiplied by root 3 will end up to be 3. Considering that we still have 2 here that is multiplied by this. So we shall have these 2 multiplied by root 3 times root 3, which will be 3. Then 2 multiplied by 3 will be 6. Easy. But the easier method, which would be by multiplying 12 and 3 together. 12 and 3, by the time you multiply it, you have root 36. And this is just straight to the point. Root 36 is going to be 6. Perfect and perfect. Now to the third example. Root 10 multiplied by 3 root 2 multiplied by root 20. I can choose to break this down by simplifying it. Like this is going to be root 5 times 2 and this is going to be root 4 times 5. Likewise, I can choose to say 10 multiplied by 2, which is 20, and 20 multiplied by another 20, which will be 400. I can choose to make use of that method too. Now to the third example. Looking at this, we can simply get our answer by multiplying this root 10 and root 2 and root 20 together. By the time you multiply 10 and 2, which will be 20, 20 multiplied by another 20 will give us root 400. And we shall be having 3 out of the root. And when you look at root 400, it's a perfect square. Root of 400 is going to be 20. Moreover, root 10 multiplied by root 2 will be root 20. And we have another root 20 here. Now let's see what we have. 10 multiplied by 2, we shall have 3 root 20. Then multiply by root 20 again. So we have it. Root 20 multiplied by root 20 will give us 20. So we have 3 multiplied by 20. So this will result to 60. Easy. Another method could be to simplify this and this. 5 times 2. We have 3 root 2 here. Now we move from here. Root 5 and root 2, we cannot do anything to that. We can choose to break it down like, okay, this is root 5 multiplied by root 2. Then we have 3 root 2 and equally root 4 is a perfect square, which will result to 2. 2 root 5. Now we can carry out the multiplication. We have root 5 and root 5. Multiplied together, it will end up to be 5. But we have a 2 outside. So that is going to result to 2 multiplied by 5. I'm picking this and this together and multiplying them. Root 5 multiplied by root 5, we have 5. Then the 2 outside here, that is why we have 2 multiplied by 5. As for this, we have 2 and 2 here. Root 2 multiplied by root 2 will end up to be 2. Then we have a 3 here. So we have 3 multiplied by root 2 multiplied by root 2, which is going to be 2. Then let's carry out the whole process together. 2 multiplied by 5, we have 10. 10 multiplied by 3, 30. 30 multiplied by 2, we have 60. 60, 60. Easy. Example. Root 3, which is raised to the power of 5. Technically, we are having root 3 in 5 places. It's going to be so easy. We shall just have root 3 multiplied by root 3 multiplied by root 3 again, and we have another root 3. 1, 2, 3, 4, then it remains 1. Root 3. It's so easy. Considering the law that was given here, root A multiplied by root A will be A. So we apply it here. Root 3 multiplied by root 3. From here to here, we have it as 3 already. Root 3 again multiplied by another root 3. We have another root 3. We have another 3 rather. Then we have the last one, which is just root 3. Standing alone. So we have root 3. Then we can say 3 multiplied by 3 we have 9 and root 3. Easy. Don't make mistake by multiplying 9 and 3 inside to now say it will be root 27. That is wrong. That will be about that for this class, which is the beginner's level. The next one will be the intermediate level. So before you go to the intermediate level, do me the honor by solving these 2 tasks given here and drop your answers at the comment section. As part of our custom, please try to share, like this video, and ultimately subscribe to this channel. I can't wait to see you in the next video, which is the intermediate level of the Surds. Thank you.